we are going to discuss chapter 2, Is Matter Around Us Pure? In this chapter, first of all, we will read about classification of matter. Anything which occupies space and has mass is called as matter. The basis of classification are physical state. Matter is classified as solid, liquid and gas. On the basis of chemical composition, we can classify matter as pure substance and mixtures. Pure substances are of two types, elements and compounds. Similarly, we have mixtures of two types, that is homogeneous and heterogeneous. Now, first of all, before we continue with this classification, we should know the basic terms which are related to the matter classification. First is atom, it is the smallest unit of matter. Then we have molecule, which is a group of atoms bonded together. Then we have element, which is actually the purest form of matter, and it consists of atoms of single type only. Then we have molecules of matter of two types, like molecules of element and molecules of compound. Molecules of element will contain alike atoms, like oxygen, nitrogen, etc. Similarly, molecules of compound will contain atoms of more than one type, like water, salt, etc. If we have to define pure substance is a substance which consists of single type of substance, that is one type of particles only. Example, oxygen, water. Oxygen is an element which is a pure substance. Similarly, water is a compound which contain particles of more than one type, but all particles are alike, that is, they are water particles. That is why we consider compound water, and that is a pure substance. Similarly, when we talk of mixtures, mixture is a substance which consists of two or more pure substances which can be separated by simple physical methods. Mixtures will include seawater, minerals, soil, air, etc. Then this is the differentiating table between element and compound, how we can differentiate pure substances also, that is in terms of elements and compounds. Like we talked of element having similar particles, similar atoms. We talk of compounds, then they will have atoms of more than one type, hence they can have two or more elements which are mixed together in definite proportion by mass. Then elements have their own fixed physical and chemical properties, but physical and chemical properties of compound are totally different from its constituent elements. Atom is the smallest particle of an element taking part in a chemical reaction. Compound cannot be separated into its constituents by simple physical methods. Now this is the differentiation between compound and mixture. We can say this is the differentiation between pure substance and impure substance, because compounds come in the category of pure substance and mixtures come in the category of impure substance. So pure substance consists of single type of substances or particles, and mixture consists of two or more pure substances or particles of two or more different types. Pure substance cannot be separated by constituent elements by physical methods, but mixtures can be separated into its components by physical methods. Pure substance has its own definite properties which differ from constituent elements, like hydrogen and oxygen are combustible, but water is not combustible. Mixture shows properties of its own component, of its own. It has properties. Example, mixture of sulfur and iron both retain their properties even after they are mixed. So the properties of mixture resemble the properties of its components. Then this is the differentiation between compounds and mixtures further. Then we have types of mixtures, that is of two types, homogeneous and heterogeneous mixtures. Homogeneous mixtures are those which have properties all alike in all the parts of the mixture, means its properties are throughout same. When we talk of homogeneous mixture, we will take into account mixtures like sugar solution, salt solution, etc. Once the sugar or salt is soluble, properties of mixture throughout the solution are same. Then here are some examples of homogeneous mixture where you see uniform distribution of the solute throughout the solution. Then we have heterogeneous mixtures which have properties different properties in different parts. So we can say there are boundaries between the constituent. For example, suppose we have sand in water. Then you see that once you allow the solution to stand, sand is at the bottom and water is at the top, and almost the suspended particles, which are very small, could be seen in the solution. So here the components have distinct boundaries. So we can say heterogeneous solutions are those which have different properties in different parts. Then when we talk of solutions further, we come across the term true solutions. These are the solutions which have actually homogeneous solutions which have two or more substances, means one solute and one solution. Then what we find, the important properties of these solutions are that they are homogeneous in nature. Solute particles are completely soluble in the solution, so they are not visible to naked eye. Then solute particles we cannot separate by filtration as they are completely soluble. Then solution is stable because the solute is uniformly distributed throughout the solution, and there are no sedimentation seen. There is no sedimentation seen because the solute particles cannot settle down at the bottom. Similarly, they cannot show Tyndall effect, that is the scattering of beam of light if passed through the solution, as the particles are small enough that they cannot actually scatter light. Then these are some of the examples of true solution. We talk about aerated rings, we talk about tincture of iodine, then alloys. They all are the examples of true solution. Then comes colloidal solutions, which are actually heterogeneous in nature, and the particles are bigger than true solution particles. And we have in colloids a dispersed phase and dispersing medium. When we talk of colloids, dispersed phase is actually same role playing as the solute in the solution, and dispersing medium is playing the same role as solvent in true solution. Then examples of colloids we can see starch in water, mixture of egg albumin in water, milk, etc. Now the important properties of true solution: heterogeneous nature, particles of dispersed phase can't be seen by naked eye, then particles of dispersed phase cannot be separated by filtration. So these are some of the important properties of colloids which are actually different from true solution. Then these are some of examples of colloid, different categories of colloid with the dispersed phase and dispersing medium, followed by some examples. Then we have types of colloid like emulsions, foams, aerosol, solid gel, etc., solid sol, etc. These are the colloid where there is a difference in dispersed phase and dispersed medium. And according to this dispersed phase and dispersion medium separation, they are categorized into different categories. Then comes suspension, which is actually heterogeneous mixture of two or more substances. Suspension has an insoluble solute mixed in a solvent, so we can see the solute in the solution itself. Now the properties: heterogeneous nature, particles are big enough that they can be seen by naked eye. If we compare solution, colloid and suspension, we can say the particles of suspension will be biggest and particles of solution, true solution, will be smallest. And the particles of colloid are midway between true solution and suspension. Then particles can be seen by naked eye. Then the particles can be separated by filtration, and you can see sedimentation of the solute particles happening here, and they are able to show Tyndall effect, that is scattering of light when beam of light is passed through this suspension. Now when we talk of Tyndall effect, it is a scattering of light by particles of colloid or suspension, and this allows the path of light becoming visible through the suspension or colloid. So the examples of Tyndall effect which you see in your daily life is when the beam of light is entering through in a dark room through a window pane. You see dust particles scattered in air. And the other example is when you see there is a canopy of trees in dense forest and a beam of light enters through that canopy of trees, you see the dust particles scattered in light. So these are the examples of Tyndall effect. Thank you. Now we are starting with second part of this chapter, that is the techniques of separation of mixtures. The few properties which we come across while taking the separation techniques into account are solubility, of the components, boiling point of the components forming mixture, freezing point, then sublimable nature and the magnetic properties. Now, when we are talking about separation techniques, we will come across following separation techniques in this chapter: evaporation, centrifugation, separating funnel, sublimation, chromatography, distillation and fractional distillation, and magnetic separation. The very first technique, that is evaporation, involves the principle that is, it is actually able to separate a volatile component from the non-volatile component of the mixture. And here we are seeing the diagram, the procedure is shown. In this case, we are separating actually the ink which is present along with water. So here the ink is the non-volatile component and water is the volatile component. Water will volatilize and ink will be left in the washed glass after heating. And you see there we are using a water bath for heating ink, because otherwise there are chances that the components of ink may undergo decomposition if we heat them directly on the flame. Next technique is centrifugation. It is actually done physically in earlier days, but now it is done by machines which is called as centrifuge machine. And the basic principle which is involved in centrifugation is that we are able to separate the heavier and the lighter particles, that is the denser particles from the lighter particles by means of centrifugation. And it is basically used for separation of cream from milk and the components of blood, and then drying of clothes in washing machine dryer and all, we use the same technique. Then we come across these figures. You see in these figures they are shown as how we can separate the different components of blood like serum, RBC, etc. And you see the denser particles at the bottom, that is the solid particles, erythrocytes, granulocytes at the bottom, and if you see the lighter particles at the top. Now next technique is separating funnel, which is actually used for separation of two liquids which do not mix with each other, that is immiscible liquids it is used for. And this is basically again based on density only, that we are able to get the two components in two different layers, that is heavier layer and lighter layer, the heavier component at the bottom and the lighter component at the top, as you are seeing in the figures shown here. The component with lower density at the top and the component with higher density at the bottom. You can see the example here: kerosene oil and water separation, kerosene oil being denser at the top and water comparatively lighter at the bottom. Then next we have the technique sublimation, which is actually involving the principle that in the mixture, one of the component is sublimable and the other component is non-sublimable. So what actually happens, the sublimable component changes into vapors and get deposited on the inner cooler parts of the apparatus, and the volatile component is actually the sublimable component, and the other component which is retained in the reaction mixture flask is the one which was non-sublimable. Here you can see in the figure also, it is very well shown here that we have taken the mixture and we are able to see on the inner walls of the funnel the component which is sublimable first changing to vapors, then on cooling getting deposited there, and the component which is non-sublimable is retained back. Like in this case we have shown separation of ammonium chloride and sodium chloride. Ammonium chloride being sublimable will change to vapors and finally solidify, and sodium chloride is retained back. Then the other technique is chromatography. This is actually the technique which is used for separation of colored components. For example, colored components present in ink can be separated by this process, and this technique is actually based on the principle that we are able to separate the component because of the reason that they have different solubility in the solvent. One which has more solubility will be rising more in the filter paper, and one which has less solubility will be rising to less length on the paper, that is a chromatography paper which you are using. So this is actually the technique is based on the solubility of the components which are present in the mixture in a solvent. Then when we say the examples, if we look at the samples of ink which can be separated by this process, then we can separate the pigments present in chlorophyll. Then we can separate proteins and amino acids by this process. Similarly, colored components in ink. Here is the example shown by means of figure, the chromatograph shown here. That is the chromatograph paper, is the paper on which actually we are allowing the components to rise. Then we have distillation, which is actually a technique based on separation of liquid mixtures. And the principle involved here is that the two components should differ in their boiling points by at least 25 degrees centigrade. What we are actually doing here is that we are just heating the liquid mixture. The components which it will be having will have different boiling points. Suppose two components are there, they both will have different boiling points. Therefore, they will vaporize at different temperatures, and one which has lower boiling point will be vaporizing first, and the vapors can be cooled and collected. And the other component which is higher by boiling point will be vaporizing later, and the vapors can be collected at a different temperature. But the essential requirement is that there should be a difference in boiling point of at least 25 degrees centigrade. Otherwise, the two vapors will mix with each other and we are not able to have clear-cut separation of the components. It is used for separation of mixtures of acetone and water, and both have different boiling points, so we can separate them by this process. Then we have the diagram which is shown here for distillation. The diagrammatic setup shows how we are maintaining the temperature, and to have an eye on temperature we have placed a thermometer also. Then we have the condenser for cooling the vapors which are formed. Then we have the receiving flask for collecting the components separately. Now another technique which is more important than distillation is fractional distillation, because this technique is required actually for separation of the components of the mixture when there is a difference of less than 25 degrees centigrade between the two components of liquid mixture. The only addition which we are doing in this technique is that we are using a fractionating column, which is actually creating hindrance for the components of the two vapors which are present in the mixture. That is the vapors of the two components. We are creating a hindrance so that they reach the condenser after some time, so that we get enough time, enough gap between the two components to reach the condenser, and we can collect them separately. So this fractionating column is just inserted to hinder the vapors from reaching the condensers fast. So when there will be a delay in reaching of the two component vapors in the condenser, we can easily separate them. This is the diagrammatic apparatus shown. Here you can see the fractionating column being added, which is actually hindering the vapors from reaching the condenser fast. Then we have magnetic separation, which is actually separating the mixtures which have one of the component as iron, which is magnetic in nature. So we can separate by this method mixture of iron and sulfur. Iron will cling to the magnet which is passed through the mixture, and the sulfur particles will be left behind. So for this technique, essential requirement is that one of the components should be iron. Thank you. We are starting with the third part of this chapter, that is separation techniques based on separation techniques only, part 2. Now in this we are continuing further with the process of separation, that is fractional distillation. And here we are doing actually the process which is used here is for purification of water. In this process you actually see that there is a reservoir from which we are taking water, and we have to purify this water. So what we are doing in this process, there is a schematic diagram which is shown here. First of all, there is water stored in a large reservoir, and it may contain many organic waste and bacteria. So what we are doing is that we are transferring the waste water which is there, or water in the reservoir, better to say, to a sedimentation tank which allow large suspended impurities to settle down. Then we transfer this water to the second compartment, that is the loading tank, where small suspended impurities are removed by dissolving this water in small amounts of alum. Alum is actually salt, a mixed salt, which is actually removing the impurities. Then we transfer this water to filtration tank for removing suspended impurities further, which can be retained within different layers of gravel, sand, coarse gravel, etc. Then we transfer this water for further sterilization. That was the physical removal of impurities. But the impurities which are removed in chlorination tank is by chemical action. That is, they are introducing chlorine in this chlorination tank, which kills the bacteria and viruses present in water and thereby sterilize water. Then we supply this water to cities through pipelines. So this water is both sterilized also and is also free from physical impurities. Next is the separation of components of air, that is by fractional distillation. Before compression, the air is pre-filtered of dust, that is dust is removed, then air is compressed into fluid state, that is either gas or liquid, and during this compression, water is condensed out. Then carbon dioxide is allowed to freeze and is removed as dry ice. Then processed air is passed through an integrated cryogenic streams in which part of the air liquefies to form a liquid that is enriched in oxygen. The remaining gas is rich in nitrogen and is distilled to almost pure nitrogen. The boiling point of argon, 87.3 Kelvin, lies between that of oxygen and nitrogen, hence they are separated by fractional distillation. The separated products are sometimes supplied by pipeline or as they were flask or gas cylinder in small quantities. Now this is the diagrammatic representation. First they have shown the steps by means of a flow chart, and then they have shown the diagrammatic representation of the whole process. So you see there are various compartments for performing different functions, and finally we are able to collect the components of gas and liquid state, and the process involved here is actually fractional distillation only. Now again a quick recap of what you have learned earlier, that is the differences between mixture and compound in terms of composition, properties, and separation techniques, examples, and components. Then we have a recap by means of a flow chart, how we can divide matter into pure substance and mixtures. Mixtures are actually impure substances. Pure substances will include element and compounds, and mixtures will include homogeneous and heterogeneous mixtures. And in homogeneous we have true solutions, in heterogeneous we have colloid and suspension. Thank you.